Hello friends, welcome back to the latest video of Start Pro course for fresh civil engineers. Now we have completed analysis of all the different elements like beams, then frames, then truss. Now in the today's video we are going to discuss about the analysis and design of G+3 RCC building. Okay, so let's begin with that. Now initially you have to draw the plan of your building. So for that purpose, now the plan is in the XZ plane. So here I am converting this grid into the XZ plane. Okay. Now randomly here you can, as per the plan, you can add the beams and nodes over here. So randomly I just draw one plan over here. Okay, just close the view, right? Then I am adding one more beams over here. Okay, now suppose this is your plan. Now whatever these openings, that all openings you have to add the beams over there. So I am just doing this into the rectangular shape panels. Okay, so now if suppose this is my plan. Okay, now it's a G+3 building. So first of all we have to go for the foundation. So selecting here the node cursor, then selecting node, all the nodes, go for the translational repeat in y direction. Let's say the height will be -2. Link steps. Okay, so this will be the foundation side. Okay, now let's take the front view. I am selecting here the all the beams. Okay, now go again in the translational repeat in y direction, ground +3. So here I have to repeat this 3 times. So the height, let's take 4 meter floor to floor height, and number of steps are 3 link steps. Okay, so now this is ground plus first, this is ground, first, second, one more floor we have to add. So take here translational repeat in y direction, 4 meter link step. Okay, so this will be the ground floor, then first, second and third, right? 1, 2, 3 and 4. 4 slabs will be there. This will be the ground level and this will be the first, second and third, 3 slabs and the ground level. Okay, now this type of model will be created. Now next job we have to go in the general. First of all let's define the geometry. Okay, now here I am defining the 2 type of cross sections, one cross section for the beams and one cross section for the columns. So let's take here first of all the cross section for beam, as let's take the depth of the beam is 0.35 and width of the beam is 0.23. I am keeping the width of beam as per the size of wall. Okay, add over here. Then take second size of cross section as column 0.3 to 0.4 and 0.3. Okay, then close. Now let's select here, I am selecting here the beam section. So select here all the beams parallel to x direction, similarly all the beams parallel to z direction, and assign the cross section to that. Okay, so first cross section is get assigned. Then select the second cross section. In geometry select the beams parallel to y, assign to beams, assign, yes. Okay, so the cross section is get assigned to this. Now here again whenever we are carry out the design, here we have to add the slab also, and for that purpose we have to define the thickness. So this is the thickness. Let's keep the thickness of the slab as 200 mm, 0.2 at all the 4 node points. Okay, so add over here, then close. Now right now here all the beams are separated. There is no any plate or no any surface. So for that purpose, what you have to do, you have to go in the front view, then select all the beams in X and Z direction. You can go in select beams in X and Z direction, or you can do in this way also, whatever I have did right now. And then go over here, fill floorboard with plates. So here 20 plates are created based on this. So now when you are selecting this plate cursor, all the plates are get selected, right? Now even in the 3D rendering view also you will came to know that this is the cross sections and this will be the plates now. Okay, now let's just assign, sorry, by mistake I have closed that figure. Start with that, to the name given to that. Structure 6. Okay, so here in the 3D rendering view you can check over here. Then next select the plate thickness, then over select the plate cursor and select the plates. Assign to selected plates, assign yes. So now the thickness is get assigned to all these plates. Okay, that you can check over here in this 3D rendering view. You have to check in the 3D rendering view that whether the cross section size or property is get assigned to all the beams and slabs or not. Okay, now after this, next is the support conditions. You have to create the fixed support, add over here. Okay, then select the front view, select all the end nodes, and see over here the bottom points are get selected. Then all the cursors over here, assign yes. So support will be get assigned to all the support. Next job is load and definition. Now here I am adding the dead load and live load. So first let's get first case dead load. The name will be given DL, add over here. Then second select the live load, LL, add, close. Now in dead load I am going to add the different type of loads. So the first load in dead load is the self weight. So self weight with factor -1, add over here. Then second load in the dead load is the wall load. Now wall load is acting as an uniformly distributed load. So here I am creating two types of wall load, on the external walls and on the internal walls. So I am creating -5 kilonewton per meter wall load on the external walls, and then half of that or -3 kilonewton per meter on the middle walls. Then next is the floor load, which is created again in the dead load. So here you have to write down the floor load over here. So again I am writing here -3 kilonewton per meter square, or you can say 4 kilonewton per meter square pressure is acting over here in global y direction, right? Then add over here. Okay, close. Now whenever you are clicking on this floor load, over here you can see it will be get assigned to this bottom floor only, but now it is available at all the floors also. Therefore you have to go in this edit and you have to define the range over here. So now starting from here 0, this will be in the -2. So here my minimum range is 0 and the maximum range is the maximum height. Now we are keeping the height as 4. So 4, 4, 4, I am keeping this height as a 15 meter maximum range. So change. Now you can see over here that floor load is get assigned to all the floors. Okay, then let's assign the self weight. Assign to view, as self weight is there for all the members. So assign to view, assign yes. Then assigning the external wall load, So for that purpose, select over here the top view. Okay, then select the external walls only. Okay, so this is the external wall. Assign to selected beams. Assign. Yes, you can see over here in the total it will be get assigned to all the floors. Again go in the top view. Now I am assigning the second load to the internal beams only. You can check over here, all the internal beams are get selected. Assign to selected beams. Assign. Yes, right. So in this way all the loads were get assigned to these members. Now next is live load. In live load I am adding a member load as a uniform force of -3 kilonewton per meter. Will be add close. Now live load will be acting on the beams parallel to x and z direction. So selecting over here, select the beams parallel to x direction, select the beams parallel to z direction, assign to selected beams, assign. Yes, right. So now here dead loads are get assigned, live load is get assigned. Now we have to do the analysis for combination of dead load and live load. Therefore select again the load case details, add over here the load combination as dead load plus live load. And now we know we are always doing the design for the ultimate load. Therefore considering the factor of safety of 1.5 for both. So here I am selecting as a 1.5 for both the loads and add over here close. So the third load is also get added in this, right. Now we are assigned the property, we have assigned the support conditions, also we have assigned the load and definition. Now you have to go in analysis and print, select over here all, add, close, then perform analysis, select the total structure, assigning S. Up till now we have, up till this we have completed in the earlier cases. Even we can do the analysis also. Okay, so here 0 errors, right. Now today we have to do the design also. So that's why here you can see in this general geometry the last tab will be of design. So when you are clicking on design, then here there are 3-4 options are get open, that is steel design, concrete design, timber, then aluminium, as well as the shear wall design. Now as we are, our building is a RCC, so concrete section, so that's why we are going in the concrete. Also you can go from here also, command, in command also there is option of design. Here you can go with the aluminium design, concrete design, steel design or timber design. Any way you can choose the design. So I am clicking over here design, then selecting here the concrete. So now here the codes related to concrete design are there. Now we are selecting here IS 456 code. Now in that one, first of all we are selecting the parameters. Now whatever the standard parameters are there, those we are selecting over here. Like for example the properties related to compressive strength of the concrete, which we are going to define, then yield strength of main reinforcement, then yield strength of secondary reinforcement, then the maximum size of main reinforcement, then the maximum size of secondary reinforcement. Similarly the minimum size of required main steel, then minimum size of the secondary steel. So likewise there are different type of properties are there which are given by default, and out of that if you want to define any particular property, those parameters you can select from here. So now I selected these parameters, then OK. Now here define parameters, whatever the parameters we have selected, all these parameters are get added over here. So first of all let's select here the FC, the compressive strength of the concrete. Now if the grade of the concrete I am selecting as M25, then here it will be as 25,000 kilonewton per meter square. Then main steel, then if I am taking Fe 500 steel, then 500, 1, 2, 3, then For secondary steel, if I am selecting as a 415. Next, the maximum diameter of the main steel. So maximum diameter of the main steel I am selecting it up to 40 mm. Okay. Add. Whatever we are clicking, all those properties we have to add. Then maximum diameter, we already did this. Maximum diameter of secondary, let's keep it up to 16 mm. Add. Then minimum diameter of main reinforcement is 10. Add. Then minimum diameter of secondary reinforcement is 8. Add. Then close. So what all those properties are get added over here, right? You can check over here. Now selecting this maximum main and selecting the whole structure, or you can select through this assign to view also. So assign, as all the section maximum steel is there, so we are assigning for whole. Then similarly same concrete grade is applied for all members, so assigning concrete grade. Then main steel, yes. Then secondary steel, okay. Then maximum secondary diameter, yes. Next, all these properties are there for all the members, that's why I am selecting here from assign to view. Okay, so whenever I am assigning any property, you can see over here there is a green color tick, means these properties get assigned. Okay, now after define parameters, next is the command. So in command you can see over here that there is a design beam, design column, design of slab or element, and take off. All these 4 commands are there. So we are selecting this design of beam, add. Then we want to design the column also, so add. Then design slab or element also, select over here, add. And here take off command, this command is also plays an important role. This will gives you the total volume of concrete as well as the total volume of the steel required in the design. So I am selecting that also as a take off. Then close. So all those parameters were assigned over here or added over here. Now we have to assign it. Now design beam, so for that purpose we have to design all the beams parallel to x and z direction. So select beams parallel to x, select beam parallel to z. Assign to selected beams, assign, yes. Then for design column, select all the beams parallel to y direction, okay. Assign, yes. Then design element, so here you have to select all the plates parallel to xz direction. So design element, assign, yes. So all the elements are get assigned over here, right? Now again we have to go in this analysis, select all, add over here, close, perform analysis, select the complete structure, assign. Now next go in the analysis, run analysis. Okay, so 0 error is done. Now here you can see the output file generated. Okay, these are the 4 warnings appeared. Okay, then notes, for floor concrete. Okay, so now this is the important note. Here what it is says that concrete quantity presents the volume in the beams, columns and the plates design above. So whatever the command of takeoff we have selected while designing, due to when you are adding that takeoff command, then you will get this type of output results, that is total volume of concrete. So here total 35.5 cubic meter of concrete is required. Similarly bar diameter, so for 8 mm bar the total weight required is 8217, then for 10 mm bar, then for 12 mm bar, so total weight of the steel required is 25,467 ton or meter cube. So it will be given when you are selecting this takeoff command. right? Now we have to go in the results. So in the result, initially you are getting this type results for the purpose of analysis. Now we just go the concrete design. So here when you are clicking on this concrete design, then here you will get that beam design results. So when you are selecting this beam design results, you can see here IS 456 is used. By using limit state method of design is carried out. Now here beam number 1, the grade of the concrete we have selected as M25, then grade of steel as 500, secondary as 415, maximum. Then here length of the beam is given 4000 or 4 meter. Then this is the size of cross section, cover of 25 mm is provided. And now here you can see the section. So beam will be get divided into 4 sections, 1 meter, 2 meter, 3 meter. These are the sections taken along the length of the beam, and along that length, so here top reinforcement of 192.13 mm square is required. Then bottom reinforcement is required at these 3 different sections. Okay, now you can see over here the summary of provided reinforcement, that is 3 bars of 10 mm diameter are provided at the top, at the end, then similarly at this end, and in between there are 2 bars throughout the length. Then bottom reinforcement, so here 3 bars in the middle and 2 bars over here. So you can see over here, in case of beam, we know the main reinforcement is provided at the bottom, and at the top there are the anchor bars provided. So here this is the main reinforcement of 3 bars of 10 mm diameter, and you can see at the end one of the bar is get bent in the top side over here, and then 2 bars are just extended up to the end. Similarly, the shear reinforcement of 2-legged 8 mm 5 stirrups are provided at the rate of 240 mm center to center. So likewise, the total, even here the shear design results are provided. This is the shear force and bending moment values are given in the beam. So in this way the design in all the beam that will be provided over here. Now similarly, when you are clicking on this column, so here is the column, cross section size we have assigned 3 meter by 4 meter, then cover of 40 mm is there, then total required area is this much, provided bars are 8 bars of 12 mm diameter are provided, which are equally distributed. Then tie reinforcement, similarly here this is a maximum shear force, then this is a maximum bending moment in z direction and bending moment in y direction is there. Likewise, all the results in the all the columns are provided. Then you can see over here that plate results are provided. Just check out that. Okay, design element from 105 to 124. So here element number means nothing but the plate number, and this is a long reinforcement and transverse reinforcement given. Okay, so likewise all the reinforcement is get designed in all the beams, columns and plates. Okay, now here you will get the total final report, but now if you want to check in which beam how much steel is provided and all that, then by using this option, like here by in post processing mode, when you are double click on any beam, here you will get the property, then here the loading, this is the shear force diagram, deflection diagram, and now one more option is get added over here as a concrete design. So when you are clicking on concrete design, then you will get the total length of the beam and the 3 sections, that is the 3 bars of 10 mm provided at the bottom, and here 3 bars of 10 mm provided at the top. Here the total details related to the length, then concrete grade, steel grade, that will be provided. Similarly, you can select any beam and you will get this concrete design. Suppose if any particular beam or in any particular beam this concrete design tab is not available, means it is not showing the results of concrete design, it means that that beam is get fail for that design. So in that case what you have to do, that you have to select that particular beam and then go in the property and increase the cross section size. As all of you know, manually whenever designs get filled, we are checking the increasing the depth of that section. So you have to change the section properties of that particular beam. Suppose similarly for columns also, when you select on concrete design, now you can see over here these bars, total number of bars are 8 bar, size of diameter is 12 mm, are provided or uniformly distributed likewise over here, right? So in this way you will get all the results for the beam and column for the design. Even in analysis, or in post processing mode, when you are going over here, then you will check this bending moment as well as the shear force as well as the bending moment diagrams for total beam, and this will be available for all dead load, live load as well as the dead load plus live load option, right? Now if you want, you can generate the reports of that. In output you can take the output results related to all the maximum minimum forces, then maximum minimum bending moments and so on. Okay, then similarly if I want to take a picture of this bending moment diagram, right? So you have to click on this take picture, and here it will be picture 1. Okay, if I am taking this shear force diagram now, again take the picture. Okay, so now you have to go in the reports, select over here the pictures. So picture 1, picture 2, print. Okay, so in this way that picture is get available in your report also, right? So likewise, after the analysis, by selecting here the design option, you can do the analysis or design of beams and columns, all the members, by using the StatPro software. Within a fraction of seconds you will get the output results like area of steel required as well as the selected diameter and corresponding spacing and all that, even for the shear reinforcement as well as for the transverse reinforcement in the slabs. Okay, so in this way you can import any type of plan over here and do the modeling and then further carry out the design. Now there is one more method to carry out the design of RCC structure in StatPro. So that method we are discussing in the next video. Okay, thank you.